sedimentologist is someone who studies sediments, whether they're grains of sand or if they're sedimentary rocks. And what we're always trying to do is work out how those sediments got there. So the processes involved, so whether they moved in a river, for example, and then what that tells us about past environments. Okay, so today I want to talk to you about something that not many people know about. So you know about rivers on land, but actually we have this amazing network of things that look like rivers on the ocean floor. In New Zealand, we have one of the world's biggest underwater rivers. This is the North Island, and we'll just do the top of the South Island here. And lots of you will know the Kaikoura Canyon, great place to go and do some whale watching. And the head of the Kaikoura Canyon, if you like, is the headwaters to this huge underwater river, which flows all the way from the South Island, all the way up past the east coast of the North Island, takes a slight detour, and then it eventually ends in the subduction zone up here. And this is known as the Hikurangi Channel. It is about 2,000 kilometers long, and at its widest, somewhere in here, it's about 10 kilometers wide. So to put that into perspective, the mighty Waikato River of New Zealand is only about 450 or so kilometres long. So it's 4 times as long as that, and it's much, much wider. So you can imagine if you were in the Hikurangi Channel, a little critter on there, the flows that must come down there are gargantuan, and they go for thousands of kilometres. And much like rivers, they bend and they move and they have lots of complicated things that happen with them. And in November 2016, obviously we know that there was the big earthquake in Kaikoura. And what happened was that the fault systems that ruptured, which were quite complicated, also ruptured some faults offshore. And what this meant was that all the sediment in the head of the Kaikoura Canyon collapsed and shed all of its sediment into the Hikurangi Channel. And we know from going out fortuitously on the Tangaroa Niwa's ship at the time that we had sediment being deposited by a turbidity current for at least 600 kilometres. And we just simply haven't been out here, so it could have gone the whole way, all the way to the Trent. Niwa and a whole bunch of scientists, including some of the students that I work with, happened to be out on the water when the earthquake happened. And so what happened was they diverted the ship, and they took a whole bunch of samples all the way down part of the channel 3 days after the earthquake happened. So this is the most fresh sampling of an earthquake triggered turbidity current that has ever happened. So we're interested in them for a number of reasons. So one, they're a really important archive for ancient climate and ancient earthquakes. And two, they're really important because they tell us of where all the sediment from the land is going in the ocean. So they form this amazing archive of Earth history.
Thank you so much for coming and talking to us on Science on a Napkin.
Thanks.